Let's run a quick simulation. Imagine a modern enterprise team tasked with launching a mission-critical Q3 marketing campaign. They have tight deadlines, heavy compliance rules, and a massive amount of data to process. In our current software environment, the humans on this team act as manual routers. To get anything done with AI, they have to manually move data between windows and type specific prompts into isolated chat boxes just to advance a single task. When an unrestricted AI attempts to speed this up, it hits a failure point known as context rot. Because the AI is searching the company's entire, unsegmented global database, it pulls irrelevant Q2 engineering specs instead of the Q3 marketing strategy. The system stalls. The human workers stop their strategic work to audit the AI's output, spending 80% of their day micromanaging bots and correcting these data errors. If they miss one mistake, agent drift takes over. A minor hallucination from a research bot is accepted as fact by a copywriting bot. These errors cascade across the team until the entire Q3 campaign simulation fails. Injecting smarter AI models into legacy chat applications cannot solve this. Success in an agentic environment requires replacing the chat interface with a mathematically bounded context container. We'll reboot the simulation. This time, we replace the noisy chat feed with a topic, a structurally bounded container for the project. When the team drops their Q3 strategy documents inside, they are instantly chunked and indexed into a topic-scoped vector store. The AI agents now have contained, relevant historical context to draw from without needing constant human guidance. We can now introduce a digital workforce into the topic. This marks a shift toward agent-to-agent, or A2A, collaboration, where specialized bots work directly with each other to complete goals. To perform complex tasks, these agents use the Model Context Protocol, or MCP. This open standard creates secure pathways between the AI and external tools, allowing agents to pull live data directly from ERPs or cloud drives. The combination of strictly bounded context and direct tool access changes the nature of the AI. The model initiates actions based on the live workspace, rather than waiting for a human to initiate every step. But autonomy creates conflict. Inside our Q3 campaign topic, a copywriter agent might prioritize high-engagement marketing copy, while a compliance agent demands strict legal caution. To resolve this, the system initiates a collision, a formal, data-driven debate where agents and human experts negotiate the outcome of a task. The system applies the Shapley value formula to weigh the causal input of each actor. By calculating the marginal contribution of each agent's data, it prevents the most active bot from hijacking the final decision. Once the agents reach a consensus, the outcome is recorded as a valid block on an immutable, cryptographic ledger. This ledger provides a step-by-step chain-of-thought audit trail. Every AI decision is now explicitly linked to the exact paragraph of source data that influenced it. Enterprise trust in autonomous systems is built on this transparency. By replacing the black box with a permanent record, every algorithmic decision becomes mathematically verifiable. The ledger tracks the assembly history, the exact sequence of past events. Using these recorded chains, it simulates and predicts workflow outcomes. Applying quantum retrodiction, the system identifies mismatches, predicting an 80% probability of a marketing asset failing a future legal review. Before the team wastes resources on a failing path, the system triggers a circuit breaker. It automatically pauses the workflow and flags a human expert to intervene. The user reviews the ledger's audit trail, adjusts a specific semantic tag to correct the agent's logic, and seamlessly approves the corrected workflow. The failure is avoided before the campaign is even launched. Once the Q3 campaign is complete, the topic enters a thermodynamic cooling phase. The active workspace archives itself, transforming into a perfect mathematical record of history. The topic ledger framework shifts the human burden from manual execution to high-level oversight. It allows teams to manage the strategic direction of their intelligence network rather than the micro tasks of their bots.